there is a poem that I read to myself a lot, and it's written by my great 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 grandpa. Not that it matters, like he's an amazing poet, but it says like این فارسی هر در که زنم صاحب آن خانه تویی تو. It says like to every door that I go, you are the owner of that house. And then it continues saying, I've been looking for you everywhere, this where, that where. But I realize you were, like in all words we try to tell each other, you've always been with me, in me. I've always been you all along.
Yeah.
So the gift of mathematics is the gift of that turning of the heads from the shadows, is the turning of the heads from, what you think, really is just the beginning. Is just like there's endless things that we can know and get more and more connected. And those things are not far. They are not behind. They are here. It's just you gotta look with a different eye. I mean, that's all the gift we can give each other, don't you? In your circling institute, it's just to say, look.
Yeah. Yes,
totally. You have it. You've been telling me the answer to your question all along. It's there. I'm just circling it back to you. Do you hear it?
Hello, and thank you for tuning in to this amazing conversation with Arezoo Islami. More about Arezoo and our conversation, but first some housekeeping. So if you are interested in participating in the ideas that we are discussing in greater depth and in fellowships, such that you can actually practice and experientially participate and experience the dimensions and the ideas and the experiences and the qualities of life and of being, to open up and to start to dwell in them in fellowship, then join this weekend into the course that is being taught by John Vervaeke, Christopher, Corinna, and myself, called Circling in Dialogos. It is a layered series of practices that culminate in dialectic into dialogos. I will put the link to register and for more information in the show notes below. That's this weekend, 7 a.m. to 1 p.m., and everything is on Zoom. Also, the Circling Institute, the main course that we teach, the Art of Circling, the practitioner training, starts November 10th. We are almost full on that course. So if you've been thinking about it and have been procrastinating it, putting it off, click on the link below and check it out, because times are running out and space is running out. We also have Circling Weekend Intensives. We have another one coming up in a few weeks. And we also have drop-in events every Thursday night from 6 to 9 p.m. Pacific Standard Time. Also, if you are interested in working with me one-on-one, I am taking clients. Just email me at guysengstock@gmail.com and let me know that you're interested in working one-on-one with me, and I will schedule an exploratory session with you, and we'll explore it together. All right. So I'm going to actually just read you Arezoo's bio, and you can get a sense of what she's up to. Arezoo Islami is a philosopher of science and a philosopher of mathematics. Interested in studying the historical construction of knowledge in mathematics and physics and the philosophical consequences of their dynamic relationship. She is also interested in investigating the contemporary notions of time according to our best theories of physics. Arezoo is an assistant professor of philosophy at San Francisco State University. She completed her postdoctoral fellowship at Stanford University, where she also received her PhD advised by Professor Thomas Ryckman on the question of applicability of mathematics. She has an MA in philosophy from Texas Tech University and an M.Sc in philosophy of science from Sharif University of Technology. Her B.Sc is in pure mathematics. So as you can tell from her bio that she is, well, first of all, she's amazingly educated. And is involved in some very, very deep primordial things in her work and in her mathematics. And you could almost get a sense, like I think most people that would read this would get this picture of somebody who's very kind of maybe academic, right, and technical or something like that. However, what you will most likely find, and listen for yourself, what you're going to hear in this dialogue is someone who is, I would say, profoundly open to the mystery that mathematics can disclose, and has a very, very soulful poetic relationship to that mystery. And I get the sense that she's really given herself to that exploration. And we cover a lot of ground. And the thing that really rings true, the through line for me, is her relationship essentially to the inexhaustible fount that is being. And that mathematics is this profound way of opening to that. Not solving it, but in some sense a way of having a kind of profound intimacy with it. It really breathes her in her being. And I really enjoyed this conversation. And we both agree it's just the beginning. We will have more. So thank you for tuning in, and I hope you enjoy this dialogue. I am so excited for this conversation with you.
Thank you.
Welcome to the dialogue. We've talked one time before, and I really got I felt like there's a multi-dimension soulful sense to you that is just it has my ear, and I want to listen to it more. And particularly, that you are, and I'll have you introduce yourself so you can kind of draw out the specifics, but you're a math professor, and however, it occurs to me that your relationship to math and also teaching math seems opposite to the picture that I think most people get when they think about math, is like this kind of technical, difficult thing. My sense is that your relationship with math is fundamentally different. I almost want to use the word, I sense the word spiritual in some way. And I also got a sense of, when we talked before, that your relationship to how you teach math and how you work with students, right, is that it sounds like math can be this huge opening for people that could be maybe even transformative for them to get this about math. And also that I know that you were born in Iran, right?
Yeah, Iran. Yeah.
Yeah, Iran. I'm also just curious about, I know there's the whole Sufi tradition, and there's a whole deep tradition, history that of Aristotle and the philosophers, and it's less known in the West, right? But there's a deep mathematical, sacred mathematics that is going on in that tradition that I don't know. I don't know if this is true or if I'm just projecting this on you, but I sense that there's something to you that is connected to that.
Yeah, thank you. So many wonderful comments. I'm also very excited talking with you. That one time that we talked was inspiring and thought-provoking, and also I find you soulful. So let's see. Going back from the last comment you made, and then we continue to the beginning.
Mm-hmm.
It is true that in Iran, and especially in ancient tradition in Iran, there is a sense that mathematics is connected to astronomy, connected to physics, connected to poetry, connected to Sufism, to mysticism. And so you find these figures like Khayyam, that is very famous in the West for his poetry about seizing the moment and being like just so alive that every second matters. And he was an outstanding mathematician, one of the forefathers of algebra, basically.
And what was his name?
Khayyam.
Ayam. Mm-hmm.
Yeah.
In what century did he exist?
I believe it's 12th century,
Okay.
11th, 12th century. Yes. So algebra is a Persian basically invention. It's difficult to say Persian or say, maybe we say part of the Islamic empire, Islamic world. It's developed in 9th century. And actually, algebra itself is really interesting because for the first time, it brings in mathematics a notion of X, the thing that we don't know what it is, but we are trying to find it. So for a moment, don't be scared of the equations you encountered in algebra. But basically, algebra is a search for discovering that which we don't know what it is, and then you find it. So prior to that, we have arithmetic that works with numbers, and then that comes from Egyptians and Babylonians, and it's been like with us for a long time, thousands of years. And then we have geometry that the Greeks axiomatized. Geometry existed prior to them, but geometry for them was studying figures, like actual things, like in space. And then, but algebra allows you this possibility of not caring about what this thing that you're trying to find refers to, but it could be a length, it could be a number, it could be a circle, it could be.
Yeah.
So in a way, the whole idea of which they called it shy or the unknown, it also maybe has something to do with the fact that they were seeking for some kind of transcendence. Now it's a hypothesis that maybe some historians can make better conjectures, but maybe the fact that you had the, like more embodied God of Christianity, and then you had the kind of impossibly imaginable God of Islam. I don't know. There was a transcendence in the culture. But when you look at these figures, they are poets, and some of them are architects, some of them are astronomers, some of them are, but you have all of it together. And growing up in Iran, not only I come from a lineage of scholars that were polymaths, like my great grandfather is called Sheikh Bahai, who is the main architect of Isfahan. So Bahai was also, an astronomer and a poet and a mystic, Sufi, through and through. But he was an outstanding mathematician. We have the results of his work. But in general, in the culture also, there is a sense that mathematics is like poetry. Now I tell you a little bit in what sense.
Yeah, yeah.
Like when you read a poem or somebody reads a poem to you, you kind of maybe see the ordinary or the words that you're familiar with, but now they are put in a way that they give you a new image, a new sense. It's unexpected. It's static. Like you have an static experience out of the very ordinary, words that you might know, phrases that are put together, right? It's true that also poets coin words, but for the most part, they use the ordinary tools to make something extraordinary that for a moment gives you that feeling of transcending. Does that make sense?
Oh, totally makes sense. Totally makes sense. Yes.
Yeah. So for me, when we will talk about it at length, but like for me, the math of like arithmetic that I studied and geometry, like other kids, I felt like I prefer to study literature. That's so much more fun.
Yeah.
It's beautiful,
Yeah.
But once I was introduced to like a more real math, more modern math, more like up-to-date mathematics, I mean, doors after doors after doors opened. And also for me, the goal when I teach mathematics to my students is not to get them, to memorize certain formulas so they can show me that they can, repeat a path, but it's more to show them aspects of mathematics that are creative, that are open-ended, and to open windows for them where they thought it's a wall that they keep hitting their head against. So the transformation is phenomenal. I've seen it. I'm so grateful to have seen it over and over and over again throughout the years at Stanford, at San Francisco State University, where I am right now, at private teachings, at many different schools in Iran, with girls mostly, with guys. It's like, but we can talk about what is happening that this transformation happens.
The sense I'm getting from what you're saying is that, like poetry, where poetry can take words that exist and bring them together in such a way, right, such that a world opens up that no one was expecting, right? A new world, right? And that's like a moment of transcendence. That what I'm hearing you say is, in some sense, math, the language of mathematics, if it's fair to call it a language. I don't know if that's fair, but I really got this. I appreciate what you said about X. Like I've never thought about that, right? But that sense of like, yeah, we don't know what X is, but the fact that there's some way that we're perceiving something that we don't know, and thus putting X there and unfolding the math through that is the process of discovering or reaching into the unknown in some sense.
Yeah. So let me give you an example, see if that works for you. So, like the most ordinary thing that we look at, like I'm looking at the edge of this chair. I mean, you have all edge of my laptop here. So it's no big deal. It's creating this like, okay, it's part of this rectangle. What's so interesting about it? And so I look at it, and so it starts from this point. Let's call it A. It goes to B. Okay, edges of this laptop. All right. But then wherever you look around you, there are these edges of things. In math, we call them line segments. But these line segments in our world, they always have some kind of thickness right? They have some kind of color. They are made like the edge of this laptop also is made out of the material that this laptop is made of. But in mathematics, I invite you to think about, what if this edge that you are looking at, or think of a rope, like a little rope, gets thinner and thinner and thinner and thinner. You say, okay, so it's a rope, then it becomes like a thin string, then becomes like thinner and thinner and thinner and thinner. But I say, like, imagine it had no thickness. Can you imagine it? I say, well, okay, there is nothing in this world, like in the experienceable world, that has no thickness, right? But in mathematics, I take you to go and think about something that starts from point A to point B and has no thickness. A line segment or a line is something without thickness, is only a one-dimensional entity. Now, while we don't have it in the world around us, now I took you to imagine something. Okay, then on that, what we are focusing on, I say, okay, so imagine on one point of this, let's call it point 0, any point you like. And then the next point after it, let's call it point 1. Okay, so between 0 and 1, do I have any other thing, any other number? You say, well, yeah, you can go halfway. Okay, call it half. How about between 0 and half? Is there anything else? You say, yeah, 1/4, like a quarter. Okay. Can you go more? And you say, yeah, 1/8. Then again, you say 1/16, 1/32, 1/64, and keep going. Will this ever end? So, no. So, no matter how much you divide that tiny bit between 2 points, it keeps going and going and going. The news is that in the world, if you're sitting somewhere, I'm sitting at point A and you're sitting at point B, the good news is that I will reach to you. But in the world of mathematics, just because we were able to make this abstraction to go to this like world of lines with no thickness, now you have opened up to the world of, thinking about, right, actually between any 2 points in this perfect, world, there are infinitely many points. So it should be impossible for me to ever get to you because there are infinitely many points sitting between us.
Yeah.
Yet we get to each other. So it's like the very ordinary thing, which is a distance between you and I, which is the edge of your laptop, which is, a rope, all of a sudden, seen from a different perspective, becomes something extraordinary.
Yeah, totally. Yeah, it sounds like, it's like, it seems to presence, at least as you're talking about it right here, it seems to presence for me a sense of something, some kind of inexhaustibility, right?
Yes.
Like, and in that sense, a kind of a mystery.
Right. And also, as you know, from it, this line with no thickness, what happens is that we are all aware, especially people that are more mystical than others or more thoughtful, they realize that whenever we have an experience of something, it's always from a particular perspective. Look, I'm looking at this wall, the rectangular wall. I see it as a particular shade of green. If you look at it, you probably see it as a slightly different shade of green, somebody else. And depending on the perspective that we have, we realize that a lot of times we talk past each other or we really don't understand each other. But what happens with something like mathematics is that it takes you to a place, because that line segment no longer has a width that you experience or I experience or another person experiences. We transcend the differences of our perspectives and our experiences. So we go to somewhere, to some place in which the difference of perspective doesn't matter, because we have arrived at a line with no thickness. We have arrived at a place that in a way is the place. Have you not heard from people that say, oh, math is universal? It's universal because it has that sense. It has the sense of difference of perspective. You know, we all culminate in, okay, so this is like, say, two fingers, you know, like, but we talk about two. Two is not something that is different from you to me to another person. So in one sense, it's fascinating that humanity has been able to now create or invent this realm in which we can transcend our differences and get to a particular perfection. But
yeah. So there's that transcendent element that you referred to earlier.
mm-hmm.
Yeah. So transcending our differences, there's like mystery there. And there's also just kind of taking, I'm also hearing, I mean, there's just something that goes on in my mind that opens up my imagination when I think about a line that has no density to it, or no thickness, right? Mm-hmm. There's just following that there. It's like something opens up there, almost like there's like a little moment of transcendence that happens there.
Mm-hmm.
I'm curious, it sounds like that you have actually in your family, you have scholars that go way back. I'm curious, you were born, what were you, as I like to say, it's like we're all born with an inheritance, right? A place and parents and families and countries and all of that. How is like, where were you born and what was some of your inheritance like?
So one can answer this question in many different ways, and all of them are long. And let me see what parts. So facts. I was born in south of Iran. It's a state called Khuzestan, which is at the border with Iraq. Mm-hmm. I was born in the wartime between the war of Iran, Iraq. So when I was 4 years of age, we had to basically move because our house was destroyed and we were war refugees. And we ended up at the diametrically basically opposite point of Iran. We are from southwest and we ended up in northeast to be the farthest one can be from the war zone. That's and then, I mean, besides the sound of the airplanes and bombs, etc., we kind of were always surrounded with poetry. So my dad is a poet, and also Iranian culture is a very poetic culture, is a very romantic culture in a way. So people don't talk very directly with each other. Even in a normal conversation, people recite poems to one another. And so I grew up fascinated with literature. I was always what you call a good student because I really liked school. But at the same time, I never quite got what the hype about mathematics was. So if you were to ask me when I was so I had we have a kind of like a French system, 20, you have like a GPA 4, we had 20. So I always had like 20 out of 20 in different subjects in elementary and middle school. But when I got to high school, I still, I wanted to be at that time a biochemist because I thought that the chemical structures are fascinating. And I was fascinated with dissecting, frogs and learning about their body. It wasn't until 10th grade that I saw what was so beautiful about mathematics. And the story goes, would you like to hear it?
I'd love to hear it, yeah.
So I was in 10th grade, and so our school has hired a teacher who already had a PhD in mathematics, which was not very common at the time. And he was the chair of the math department in basically like top first institution in Iran. So he really didn't need to go to teach high school students, but he had realized that this is where the foundations are formed. And I would love to teach in high schools also because students are mature enough, but to get the abstract level of mathematics, but also they are not so kind of like rigid as in college. So it's a really golden moment. And he has decided to go to a girls' school, like in Iran, because of the political system, we have all girl and all guy schools. So it was an all girls school because he also believed that women are fascinating in mathematics. By the way, we don't have that in Iran, that like it's mathematics is not considered to be like an all male, area. Sciences are not. Our women are very, very good. And anyhow, so he walks in the class, and the first thing he told us was that I want you to throw out your high school textbooks. So we were like, yay, in mathematics. So there's a national system in Iran. Everybody studies the same thing. So those things we just thought, great, we will make a bonfire, burn our math books.
Yes.
And he said, I want you to get the college textbooks. So I'm in the 10th grade. We jumped 3 years.
Wow.
You can imagine some students were really like scared, some were excited. So we were like, are you sure? I mean, 3 years, and I was already in a very good school. So like 3 years meant we kind of bypassed the calculus and a little bit of algebra and some kind of like discrete math, etc. It was a very heavy school in terms of mathematics. He wanted us to jump. And what happened is that we started from the most basic stuff that all humans maybe would agree on. We started from logic, principles of thinking. We started from like set theory. And he said, you got to promise to me you will never memorize anything. So the methods for checking were sometimes he would say, okay, you have an exam in like 2 weeks. Promise me not to study for the exam. So I really like that idea of not studying for an exam. Okay, when you're in the class,
right,
you're either getting it or you aren't getting it. Just don't study. So, oh, great, let's go. So what he did is basically he took us to this world in which we started from like just the most simple ways people can think. Like, for instance, whether you have a light here, whether it's on or off. Do you agree it's either on or off? Okay. So, and eventually we moved to like the study of a little bit of what I told you, lines, and study of these notions in calculus are called limit and tangent. But we were seeing everything. Like I remember we had this hour and a half class followed by 45 minutes lunch break. Very often they would ring the bell for the break. Nobody was hearing it in the class.
Really?
We were like flying. My experience of that class was I was flying in the sky with these ideas of how you move. Like he would say, okay, just imagine you are like between 0 and 1 that I talked to you about, but imagine you're this very tiny creature that moves from 0.1/2 and wants to get close to 0. Like make it bigger. How many more numbers do you have to pass to get to this? How many more? Get it bigger, get it bigger. This is a notion of limit in calculus.
Yeah.
And so 45 minutes would pass and the next class had started and we would just like be all,
Mm.
speechless that we were together in that world. So he would write poems for us, we would write poems for him. Like, this teacher understood that for us, mathematics was this thing beyond rule following, beyond, and he taught us, he put us in the place of mathematicians for us, because mathematics is not about, just put one step on top of another, but actually in mathematics, you have a lot of contradictions and paradoxes, and you're trying to get out of them so you can invent something new. So we were learning that. We were putting ourselves in the shoes of mathematicians that have come before us, and it was so intuitive.
Wow.
That was my beginning. And so I would get so excited that if he were giving us 50 problems to solve for the next week, I would do 500 problems, because I just thought there's nothing more fun than this. So I would listen to this heavy metal music,
Yes. Yeah.
do math problems.
That's amazing. Would you say, was it from yourself at the time? Was it like, was the experience of like, was he opening up like new worlds that your imagination could move in? Was he disclosing things that were already there? They were just hidden from you in that moment. What were the elements of the things that were opening up in that?
So several elements. One is that, have you noticed that if somebody tells you, oh, look at this, you might look or not. But if somebody is just looking at something and with excitement, and you're passing in the street, you can't help it but to look at what is the object of their gaze.
Yes.
So first of all, what we saw in this person, and I think this is what you see in all really good teachers, is that you get to experience them in the presence of their beloved. You get to experience them in the presence of this gorgeous thing that they have fallen in love with. In this case was this mathematics, but studied not from a rigid point of view, but from the point of view that keeps asking, why? Why should I do it this way? He taught us this first. He said, before we do the what of this stuff, feel free to ask why. Like, yeah, why? Why is it that like the internal angles of a triangle are 180 degrees?
Yeah.
Why is it that like, what? I just want it to be 200 degrees, And the answer wasn't, no, that's just the way it is. But the answer was, how is it that we have arrived at something like this? Can we think differently? And the later part of my life is me falling in love with philosophy, which is allowing you to imagine even our mathematics could have been different. But in this experience of high school, it was more going to this new world that, as I described it, it was this transcendental world. It was somewhere that, and for me as a teenager, who was fascinated and really struggling with questions of existence, who am I? Like, where is my place in this world? Like, what is all this about? Yeah. Mathematics came to be like leading the way. It was an opposite of poetry and mysticism. It was like that, because one of the first concepts we were introduced to was this notion of infinity, which is, so what does it mean? Like if you even look at the normal numbers from that point of view, I don't know if you've ever thought about it, but like as a kid, I was thinking, okay, so here is 1. If I start counting, there's 2, here's 3, here's 4, okay, 5. How many numbers can I count in a day? There's a specific answer. How many can I count in a year? How many can you count in your entire lifetime? I hope you live for many 100 years, but it's a particular number. But even if you spend your whole life not doing anything else and just counting, you haven't counted that many, have you? Because from the moment, imagine you count till like 1 trillion or something, or whatever that number is, call it n, still there is that many more and way more numbers left. So it's for the first time that we encounter, a place that it doesn't matter how much you are progressing, you haven't progressed any, because a finite part from 0 to that number that you count is insignificant comparing to infinity.
Yeah.
And it's fascinating, it's mind-blowing. And then you learn that this infinity of counting numbers is the smallest infinity known to us. There are so many other levels of infinity. I was blown away when I was in 10th grade and I heard this many, the numbers is the smallest infinity we know. It's like, wow.
Yeah.
How much bigger can something get than infinite? Much bigger. So this is what we call Aleph zero, the cardinality of this set. And then there are more. One more thing I want to add to it is, it's fascinating that even though we know this collection of numbers is gonna be bigger than your whole lifetime and your children and your grandchildren and your great-grandchildren and every human that comes after you forever. We still in mathematics say, okay, let's call this collection of all these numbers n. It's one set, is a set of natural numbers.
Yes.
So in the same way that that line segment, even though it's a world unto itself, you can never study it sufficiently. It's so many numbers are there. The properties of it are fascinating. Same goes, but math says, allow me to transcend your temporality, which I'm sorry, you, me, we are gonna die one day. Doesn't matter, and our children are gonna die, but we are gonna get the essence of all that temporality and create this atemporal entity that is natural numbers. I mean, every kid knows about natural numbers, but they don't realize, is that fascinating? Natural numbers are not very natural.
Right. Wow. So man, so many things in just what you said that I'm responding to. Mostly I'm feeling you're evoking a sense of wonder over here, right, in me. And I really get that that's actually what it sounds like is what that teacher invoked in the 10th grade when you talked about, and especially when you talked about the beloved, like he was showing mathematics as, but it was the face of the beloved that he was actually showing. And I suppose, like, in that way that this, because it's funny, usually people don't think about eros and math, right? Eros and numbers, they think about those as opposite, but like the way that you're describing it, it's almost like the that love. And if we say eros is something like I want to completely consume something and be consumed by it, right? That erotic relationship to math. It sounds like you really evoked that for you at that time in your life. I mean, it's still coming through you. I mean, I don't get the sense that you're any less, in a sense, like you have. I have this feeling that you are still 10th grade hasn't stopped, right? You're still awing. You're awing.
I'm glad to hear. So it is really awe-awakening. And I've witnessed that many times. Like I tell you a story at Stanford, when I was a PhD student, we had these summer programs called Educated Program for Gifted, Talented Youth. That as a starving PhD students, I would take up these summer teachings, and excellent program. They would invite students or students from all around the world, middle schoolers or like high schoolers would apply to get in for one course. So I had the honor of teaching some of these courses, and I would teach a college level mathematics to say 8th graders.
Wow.
7th graders.
Wow.
Abstract algebra, number theory, fascinating. So these kids would come. So of course, some of them themselves, some of them, their parents have chosen that the kid spends 2-3 weeks in their summer doing this. So most of them were what people call good at math. I don't believe there is such thing as good at math. Everybody can be good at math, but good at math. And so I would go to the class and say, to use their own terms, I would say, don't you think math is really badass? It's like really cool.
Yeah.
And the kids were like, no, the only thing that math is not is cool, you know, like, so like
yeah.
But so what I'm gonna do, and my syllabus was each time I would pick what a working mathematician says it's a beautiful formula. So for instance, in the middle school, I taught them something, it's called Euler's identity. It's e to the power of I pi plus 1 is 0, anyhow.
Yeah.
And I would pick every area of mathematics they need to know in order to be able to experience for themselves that this thing is beautiful, right? It's like if you are a poet, if you teach people, you know, the language or the structures they need to know to see this beauty. So, and that's maybe a difference of, say, math with maybe like visual arts, but maybe not. So there, from basically 2/3 of the class on, I would hear my students sitting in the back, and you know, like when students get excited, they do this, like, you know, and then I would hear these little kids sitting in the back saying, oh my God. And that was the moment that they got it. Like they would see the thing that they've been doing, like, because math we do since maybe like first grade, they have been doing it and they were so-called good at it. It's interesting. Yeah. I still receive letters from my students. That's like one of the most amazing pleasures of a teacher's life, from those students saying, you know, now I'm a PhD student in mathematics at MIT, at Harvard, at Princeton, at wherever. Your 2 weeks of teaching us, your 3 weeks of teaching us made me fall in love with math, because I saw that this thing, because in a formula like what I was telling you, Euler's identity, you can pick many such formula. You just see such unexpected connections. You see like an imaginary unit connecting with geometry, connecting with natural numbers, connecting with group theory, like things that you thought are completely disconnected, they get connected, and it's so interesting and unexpected. So to me, mathematics is like anything. Like I can't make you fall in love by, you know, like just say, oh, you got to fall in love with this thing. You got to experience that in your body, that this thing is fascinating. So that's the journey, and that's what I kind of try to take my my students at San Francisco State, or college level students, and at Stanford, to experience that for themselves. And then once the person has experienced it, it's the point of no return.
Yeah. Well, so it's also, I think I'm appreciating too in what you're saying, how in so much your love of mathematics has this really relational quality, right? Of that, it sounds like in some sense that teacher was able to transmit his love. Like, and it sounds like as it and honestly, it's exactly my experience of as we're talking about math, when I think about math and you, it's the beloved. It definitely is the beloved, right? There's a inexhaustible an inexhaustible shining forth, and also a withdrawal into the mystery that just I just get this sense that it's so present for you. And when you said that thing, and this is one of the big mysteries with teaching, right? I've noticed as well, which I think about a lot, which is on some level, you can't really do that for you. There's one level where you can't teach somebody to like it, but there is something in that relation, right? That affords the love to catch, the wonder to catch. It's kind of like, I would imagine it's similar to in the Socratic dialogues, right? Where, they're talking about a virtue, and they get to this point where you can't describe it in language anymore. And it's this big question about, right, well, what is courage? And like, how come you can't define it? But then all of a sudden you see in the drama, the dialogue, that everyone's being courageous, right? In some sense, Socrates was afforded this dialogical relation, this dialogue, this deep dialogue, this relations, right? Such that courage could be caught, right? The virtues can be caught. And I'm getting a picture of that, of you, and it was in 10th grade, right?
Yeah.
Yeah.
Yeah. So when you say it's relational, in a way, at some point one learns how to interact with, say, a written book, or because a written book also, you have a relationship with the author. So one thing that I learned very early on in my education is to be able to pick up also a math book and read it like it's any book. Like, don't be intimidated. It's also, it introduces a bunch of characters to you, and but at the same time, prior to getting to that point, there is a sense that we are intrigued and inspired by things that are alive, So there is a sense in which you got to be able to see the aliveness of dealing with mathematics and the aliveness of the mathematics itself. So what we saw was that math is not this ruler that is kept over your head, and if you don't do it right, you get hit. And so when I go to my classes, and at SF State, I teach this class that is mathematics for arts and humanities majors. So the students that have not really wanted to take this class, it's a requirement of the university. And so they see I'm teaching a course called Arts of Quantitative Reasoning. So they come in, at least it has some art in it. And the first session, I've come up with this idea about how to ask them a question in the right way. Because if you say, do you like math? I did it in the beginning. I say, is there someone, if you like mathematics, please raise your hand. Nobody does. If you don't like it, like if you hate it, raise your hand. All of them do. That's not helpful. So I've devised this kind of thought experiment. I say, like, imagine that mathematics is like a lover of yours, is a beloved of yours, and describe the current status of your romantic relationship for me.
What a gorgeous question.
Yeah. So make something that is like dead, turn it into something that is alive. Some of my students have come up with all kinds of hilarious responses. Some of them say, oh, it's it's kind of a arranged marriage. Our parents forced us to get married.
Right.
And we are trying to, I really don't want to be in this relationship, but math keeps calling on me. Some of them say we are in a BDSM relationship. Math beating on me. A lot of them say divorced. Some of them say, like none says it's a good relationship. But I asked them a second question. I say, okay, so what would you like your relationship ideally with this lover of yours to be?
Yeah.
And almost everybody says, I don't want to hate it. Like, I want to get what it is. Like, I want to get it. Maybe we choose to have a relationship, maybe not. So that's a good opening. And then I asked them, okay, great. So they say, okay, we want to have what is the term? Like a more mature, breakup, like more conscious uncoupling.
Yeah. Yes.
And I said, what are you willing to do in this 4 months of a semester?
Yeah.
Okay. They're like, I can be open. So as the time goes on, I continue playing with this metaphor. I said, how do you feel?
Mm.
So I have letters after letters after letters from students that saying, I couldn't imagine that something that has been the cause of me losing my confidence all throughout these years now has become something that is interesting. Like all of a sudden, the world has a different music. Now, some of them say, had we had a course like that, we would have wanted to be math majors even. And some say, okay, great. I heard this beautiful music. It's beautiful. It's interesting. I don't want to be a mathematician, but now I can see what's interesting about it. So throughout this, we lift the confidence of our students. We open windows for each other. And to me, this is the most amazing gift. It's almost like therapeutic. It's almost we give each other the gift of overcoming a fear.
Right. Totally. Totally. Yeah, there is something transformational, it seems, right?
Yeah.
About like in just in the sense of just invoking the question of like mathematics was your lover, right? Like, what is your relationship to math? And it's so interesting because I wonder about, you know, um, I would say I'm just right at the edge of explicitly of math. I've read a lot of philosophy and written things in that kind of sense, but not haven't really dove directly into math. I'm I have a book on sacred geometry that I'm going to just start like like walking through. But I have this sense of where I've wondered about that I that I it, that in some sense there it seems like math and what's going on in mathematics is like so at the heart of everything in so many ways, right? That even if I decide never, if I decide to divorce mathematics, I can't ever, I have this sense of like, I probably can't ever actually divorce it, right? Because in some sense, I'm made of it. I'm made up through it, that there's something so integral to the very, well, that the universe has a structure, right? That being has levels of intelligibility. Like all of these notions have a structural mathematic element to it. So I'm interested in that sense in which, in this way, I can hear kind of Heidegger in the background, um, of this way you're, in those terms where he talks about you are always already, right? Always already in a world, right? I'm not that has a world. I am the being in the world. That sense of a deep immersion in math. And I could just imagine that if I dive into math, that like as I understand it more and get closer to it, that I have a feeling it's going to be one of those things where it's like, oh, I'm immersed in it in some way. It's like so fundamental.
Absolutely. So sometimes the analogy I have for myself is that imagine in our world, somebody would come to you and say, I hate music. So you say, really? You hate music? You mean you hate playing music? Say, no, like music, I hate. Like I just like I'm scared of music. I don't like music. So it's a very sad situation,
Yeah.
not for maybe you, for that person, you feel like they are deprived of these like amazing moments in which you experience something that is so fascinating, so out of this world. So it's basically what gives a lot of experiences their, you know, their color. It gives them. So even if you might not be a person who listens to music day and night, which I do, is you're still feeling like that person's life experience lacks in a substantive way. So when I moved to United States, and that's when for the first time I heard there is such thing as not liking math, because that's the very, maybe it's an Anglo-American, I don't know what it is, but I had never heard in Iran, even if you're an artist, if you are a literature person, if you're like whoever you are, people like math. I mean, you might not be a mathematician, but it's part of the culture. Like I had never heard somebody saying, I hate math. Like it's a very,
Be
in
like
my mind, it's a
someone
very
saying I hate
American
music.
thing.
Yeah, right.
So then I feel like that person now replace math with music or replace music for math. What you're realizing is that isn't that such a sad thing for a majority of a nation, that not to love, you know, not to appreciate, not to see mathematics? Now, if you put music, you would realize the significance of it, because as you rightly said, it's everywhere. You could say, I don't like music, but you know, from the elevator you get in to the cab you get into, like everywhere there is music. But not only it's everywhere, it's such a sublime aspect of human culture. If you don't like it, if you're scared of it, if you are, you know, who is deprived of it? You. So one of my dreams is that to give this gift to this nation that has accepted me, you know, as a member, give them the gift of seeing something, that seeing like this music of this world, call it, that is mathematics, is just like the music they're always listening to, but they would have been deprived from it had they been resistant to wanting to learn it. So you see what I'm saying? It's not only that it's useful. So when I go teach these classes, my colleagues say, oh, tell your students that math is useful. The issue is not that the students don't know math is useful. Everybody knows it's useful. They just don't see its beauty. They don't feel connected to it. They don't see its spirit.
Yeah.
When you were introducing me in the beginning, you said, I know you are a math professor, so I teach mathematics, but I also teach philosophy of mathematics. I teach philosophy of science. And that has been super helpful. When I fell in love with philosophy, it helped me to even bring mathematics much closer to humans and to make it human-centered, more than there is this like something in the Platonic world that if you're lucky enough, you get access to. But looking at the history of mathematics and the questioning of, does it really have to be the case that something is true or false? Like, so like, are we here or are we not here? Because that's one of the foundations of math, that everything is either true or false. But then the person who dared to ask that question invented a logic called fuzzy logic, which is the basis for our dimmers. You know, I have a dimmer in my room. The light is not either on or off. It could be a little on, a little bit more, a little bit more, a little bit more. Isn't that fascinating? It's not on and off switch. Okay, great. So it's a different logic. It's a different way of thinking about even, so that's the philosophical reflections about math. So I also invite those in my classes. I say, question everything you want. You think
Totally.
1+1 shouldn't be 2? Great. Let's talk about that.
Yeah. Which philosophers, when you got into the philosophical aspect of math, which philosophers or what kind of philosophy are the ones that really hit you? I'm sure there are many. I mean, it's probably a question to answer.
There are many, and I'm going to choose not to name philosophers, but to tell you that also my love for philosophy, which philosophy itself is a love, it means love of wisdom. Philosophy is a very romantic area. So I'm very surprised when people think either you are an artist in touch with emotions and romantic things, or you are a philosopher who does very like dry things. I mean, philosophy is a love for wisdom, which is alive. Wisdom is not like just knowledge that, wisdom has always that turning of heads. Wisdom always has this paradigm shift in it. But for me, philosophy in general as an invitation to look at what you have taken for granted, so I think I'm standing on a hard, surface. Philosophy is the invitation to look and see that sometimes this is not such a hard surface. I'm actually standing on a boat in the middle of this, stormy sea, that you always realize you're making certain assumptions that are not that well founded as you think. So the awakening that comes, maybe like we live in an age that people say experience psychedelic states, they experience, through breath works, etc. Some of what they experience is this realization that what I had taken to be like set in stone is not true, is my story.
Yeah.
So philosophy, when it's done well, is that it says whatever you think you're 100% sure about, that you think the reality is like that, become aware that this is also just one perspective. So philosophy woke me up from my dogmatic slumbers, that I realized the mathematics, no matter what line of mathematics I love, that line is just, that field is just one, that I can start with, say, other assumptions. Like I can move from Euclidean to non-Euclidean geometry. I can move from logic with 2 values to infinite values. I can move, and it's fascinating. World after world opens up that allows further reflection. And I think this is a gift that philosophers can give to mathematicians. It's a gift that has not been much well received because we are all humans and we have all our biases. But I think through this collaboration, a lot of amazing things can come about. One thing I want to add to it is that when you look at, say, forefathers of quantum mechanics, when you look at Einstein, when you look at the history is full of scientists and mathematicians that were avid students of philosophy.
Yeah.
We have lost that.
Yeah.
And it's a big loss for humanity.
Yes. In the Platonic Academy, didn't they had something like a sign on the front door that said only enter if you know geometry or something like that, right? There's this deep wedding, right, from the very beginnings of philosophy, right? I'm curious about that particular, just your sense of this connection between the Platonic Academy. Because I know in Plato there's lots of math going on there. There's like the eidos, right? All kinds of things are connecting there. I'm sorry, could you? Of course, there's a weed whacker that just started. Can you hear that through the? No, you can't. Okay, good. This sense, this connection. I'm curious about what your thoughts are about this essential connection between the Platonic Academy and geometry and math, and those two coming, those deep, like that deep weddedness that's going on there, such that they say like, don't enter unless you know geometry.
I'm sometimes tempted to put that sign outside of my house or my office, but
Right on.
So you've heard the allegory of cave, right?
Yes,
So
yes.
this sense that for the prisoner of the senses, like which are supposed to be all of us, we mistake shadows for the reality, right? So we are chained in the sense, in the world of the senses. We are these prisoners that we have our back to the wall of, we have our back to the entry of the cave. And the reality for Plato is like, outside the cave, these things are moving, but inside, and there's a fire outside, but I'm only seeing the shadows of them. So the awakening, and I would love to hear from you when you mentioned spiritual, like in what sense it has to do also with that awakening. But for the awakening for Plato, we have to free ourselves from the shackles in which we are born. And the shackles are us taking our experience to be the reality. You know, isn't that where all of the suffering comes from?
Oh yeah, totally.
So the question is that how do we get to, as prisoners of in this cave that Plato is talking about, how do we get to, first of all, realize that we are prisoners, that realize these are shadows, these are not realities, and what aids us in, breaking free from these shackles and seeing the reality. So in one sense, now we go back to the beginning of our chat, our conversation, that you are able to identify things that are beyond our sense perceptions, that are beyond our perspectives. The means by which we are able to talk about line with no thickness, we are able to talk about infinity, we are able to talk about, groups and rings and fields, and, that means is the light of reason. So mathematics, in a really important sense, is an experience of transcending, is an experience of using your reason, your rational mind to go beyond what you're experiencing, to go beyond the senses, to go beyond the differences. Yeah. So to me, somewhere you got to experience that, like where in our life we experience these like awakened moments, and then practice it, stay focused with mathematics. What is your sense of that?
Well, I'm curious, would you say your experience with the teacher in 10th grade, that whole experience that you so beautifully described, was that a moment of coming out of the cave for you?
I go in and out of the cave all the time. Don't you? It's a practice, it's a perpetual awakening. I think there's a cave in a cave in a cave in a cave. Yeah. But that's one of the moments that I realized beyond or behind what I had taken to be the entire world, there is like a fascinating world. In a sense, when we discuss quantum mechanics, when the first time they tell you, look, that star or that thing, shiny thing that you're looking at in the sky, is not there anymore. It takes time for light to get to you. So that thing you're looking, so it's just the very thing you've been looking at now becomes something else. So science has this, to me, magical quality that says, look, I get it. It feels to you the earth is now moving. I appreciate you telling me it feels to you the earth is flat. But if you just zoom out, or if you are able to, like for a moment, imagine It's not the sun that rises, it's the earth that is moving. That you're feeling,
Yeah.
that your perception is misleading you, but the reality is something different. That's a
Mhm.
waking up, that all of those moments.
Yeah.
So mathematics helps you with sharpening of
Yes.
capacity to think rationally, the capacity to reason.
Yeah.
So you are able to transcend and transcend and transcend. So
Yeah. Totally. Totally. Yeah, because it does seem like the just the awareness that there is a domain called, we'll call it that X, right? There's X, like that there is that I could get it like math is, if we look at math as a um as my friend and colleague John Vervaeke would say, as a psychotechnology, as a practice, like philosophy in the ancient sense was indistinguishable from the practice of philosophy, right? Um, and so I would imagine mathematics in that similar way would be this spiritual practice in a certain sense, exercising the machinery of logic, of reason, in such a way that it's continually showing me that there's so much more there going on than I could have even I couldn't have known that I didn't know, right? This and I think that's really been my experience with philosophy, is just domains open up, dimensions open up, for which um well, on one level, what's interesting about it is dimensions disclose, which presupposes that they were already there, but I didn't see them. Just realizing that there is such a thing called, like, the dimension of what is so close to me, it's concealed perhaps in its obviousness or its nearness, right? Phenomenology is that sense of things, right? So I would say that there's one part of getting out of the cave, I think, for me, is just having these practices that keep disclosing the kind of inexhaustible mystery, right? Um, and specifically, yeah, specifically, because so much of wisdom, right? So philia sophia, philosophy, right? Wisdom, love of wisdom. So much of wisdom is about, has to do with um the minimization of self-deception, right? So there's this whole part of kind of recognizing, like, my own illusions, recognizing, right, that the thing I thought was just absolutely true, like, is not only not like I thought it was, but there's a whole world underneath what I thought, right? That was there the whole time and I didn't see it. There's something about that experience of kind of, because when one recognizes that one has been in a cave, taking the shadows to be a world, right? In a reality, it's like there's recognizing that fact, but then there's also recognizing that I didn't recognize it, and that that didn't, right, is it seems to be a big part of all genuine spiritual practices, is kind of recognizing that kind of, I guess, intellectual, right, and even I would say ontological humility in some way, in a huge way.
right. So a couple of points about that is when you look at the history of science, to me, science, because you know that what we call natural sciences today, they were also all part of this philosophy. And then they got more specialized and distinct. But when you look at what is it that makes physics physics, is that is also that turning of the head, turning from what we had considered to be the truth to something else. Like we still in the day-to-day jargon, we still say, oh, look at the sunrise, sun is rising. Sun is not rising, sun is not move, so in a sense, it's the earth that is rotating. But so what is it, the cause that led us to move from, say, one paradigm to another, move from thinking it's the sun that rises to the earth that is rotating, or to move to quantum mechanics, to relativity, is also mathematics. So mathematics has become this telescope with which we look at the very far and very early, like nobody was there at the early stages of the universe. You know that, right?
Yeah.
Like we don't have fossils about the Big Bang.
Yeah.
So what is it? What is the best tool that we have that tell us, yeah, most probably there was such thing as like, some kind of an explosion, and maybe like it was a there was an eternal inflation before that. There were universes coming about. And what is it that gives us this reach into the vast and into the small and into the early and into... It's mathematics, because on the basis of, say, we look at the map of cosmic microwave background, we have some data, but the data by itself doesn't say anything. So we say, okay, so I use my inferences to say, okay, that means that, okay, there was this property, this event happening, and here is, I measure, or I give an equation by which this has happened. So then if we have better tools, we go and, at the time of Galileo, nobody could do these air travels that we are doing. Nobody was doing this, so the possibilities, the worlds that have opened up to us right now, even like, the plane that you're using that travels from like one point of the earth to the other one, the GPSs, they use corrections of the Einstein's relativity. What was Einstein doing? Trying to put together two sets of mathematical equations of Newton with Maxwell.
Yeah.
What was Maxwell doing? So in a way, mathematics also plays that role of giving us, is almost makes us giants. Like we are so small, and our sense perception is, our senses are deceiving us a lot of times. But not only it gets us behind what we are looking at, but it actually extends our reach in the universe. We comfortably talk about the universe. I mean, you and I talk about dark matter, dark energy. Nobody has seen dark matter or dark energy. All the calculations are done using mathematics.
Yeah.
All our physicists use math. All our scientists use math. So it has all these fascinating also capabilities that allow us to go in, in far and in the small. And so I also find that fascinating.
What would you say? I just got that real sense of just, you were using, like, I loved your hand gestures, is like all the places that like math kind of reaches, and these different ways that it reaches into what we have like some evidence, but we have to infer a lot, right? And so we do math in these different ways to disclose this thing that we don't know. What would you say? I guess this is kind of a big question, but what would you say? What is it that wants to know? What is it that is inclined to even bother to reach in the first place? Would you say that which wants to reach is very is it part of the spirit of mathematics? That which wants to know and to reach into X. And what is most
asking hard questions. Wants to know, in a sense,
Yeah.
Like, what is this
Yeah. Yeah.
consciousness that,
Is that what you say it is? Is consciousness?
I mean, what is it that wants to be known, or what is it that wants to know?
Yeah. I also like the other question too, right? Right. Which is, what is it that wants to be known? Because I think that's my experience of it a lot. It's like, I can't quite tell, the unending, right? The unending kind of sense of wonder and reverence for seeing more, listening more, like more and more of the mystery, and wanting to get as close to it as possible, right? That feels in some way, on some level, it feels like it's from here going towards that. But in another way, it has much more of this sense of where it feels like that I'm its occasion to some degree for its self-disclosure, right? In some way. And I think this is one of the things that just seems to be something that seems to be so beautiful about people, right? And about human beings, is it just seems to me that we seem to be, I ask myself this question sometimes. It's like, why did the Big Bang grow a nervous system? Right? Like there's something, like there's a way where, if we want to call it consciousness or human being or something, we are that way, that all that is, in some sense, is beginning to ask itself what it is and disclose itself to itself. And as I'm saying that right now, I'm sensing that in some way, that's what you've been pointing to through this whole conversation, right? With math, is my sense is what's behind this is this wonderment, this deep sense of wonderment about, I don't know, is it being, about existence itself? Like I sense that is that what's at the bottom of mathematics. It seems to be very, very, in my perception, it seems to be very strong in you.
So,
Sense of wonder.
yeah, this is a question mostly for you. I do not dare to go in this ocean, although we are all born in this ocean, and that it's a sense of, when you were saying something is relational and something is yeah, it's all ultimately a sense of being connected and going to where words fail. That I guess we all have a sense of it and have a grasp of it in our existence, that it's the beloved of everything and it's the ex of everything. But what I have noticed in relation to mathematics is it first of all gives back to people themselves. So for me, anything that you can do for other humans that gives them this sense of empowerment is appreciated, because ultimately you don't know much, I don't know much, nobody knows much. Like, the sense is that if anybody knows anything, is like all of us, if we dig deeper, and this, for the lack of better term, this universal consciousness that is getting to know itself. I do not dare to speak in that realm, but it's more like giving each other the gift of ourself, like giving each other the gift of, this is not an insignificant being, and something that you think you know about who you are and about yourself, that also is like a shadow. I mean, what you think you are and who you think you are is also something that's just a starting point. You really have no idea who you are, what you can do. Like I experienced that in romances a lot, and I experienced that with myself since I was a kid. I was always thinking that I'm the biggest question to myself. I have no idea. Like, who are you?
Yeah.
But because we have put a name on it, I said, okay, Arezoo Islami, and yeah, that's my life story. We kind of make the biggest mistake ever. Like, there is a poem that I read to myself a lot, and it's written by my great 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 grandpa. Not that it matters, like he's an amazing poet, but it says like, این فارسی هر در که زنم صاحب آن خانه تویی تو. It says like, to every door that I go, you are the owner of that house. And then it continues saying, I've been looking for you everywhere, this where, that where, but I realize you were, like in all words we try to tell each other, you've always been with me, in me, I've always been you all along.
Yeah.
So the gift of mathematics is the gift of that turning of the heads from the shadows, is the turning of the heads from, what you think, really is just the beginning. Is just like there's endless things that we can know and get more and more connected. And those things are not far. They are not behind. They are here. It's just you got to look with a different eye. I mean, that's all the gift we can give each other. Don't you, in your circling institute, it's just to say, look.
Yeah. Yes,
You
totally.
have it. You've been telling me the answer to your question all along. It's there. I'm just circling it back to you. Do you hear it?
Yes. In some sense, there is and was when you responded to my my question about it, there was a tenderness I sensed, right? I felt it in you, I felt it in me, but it felt like it opened between us, something transjective almost. That tenderness I felt in some sense elucidated what that question was opening up to, right? In a way that probably any words you and I could say couldn't quite do. Mm-hmm. Really nice talking with you.
Thank you. Same. Yeah. Thank you for your time and for your tenderness.
Yeah, let's, if you're open to it, like I'd love to schedule another one and let's continue the conversation.
Sure.
Yeah.
You're not bored yet. I'm fascinated.
Thank you so much. And then I'll get whatever contact ways for people to contact you. I'll put it in the show notes in my underneath YouTube and all that. So thank you so much.
Thank you. To be continued.
Yes.